have a look here now. If I put all these nuclei up here. Oh, that's nice. Let me pause that and reset all nuclei. So here now I have, this is a lot more. Actually, you know what? I think this is probably going to work better. So these are all individual carbon-14 atoms that I've laid out on the screen. And what it's going to show me is the percentage of carbon-14 remaining. And by the time I get to 5,730 years, it should be like at the 50% mark. Let's see what happens. And there we go. So when you get to 1 half-life, you can see here that about half of those carbon-14s have turned into nitrogen-14. And the numbers here, because we have 1,000, I forgot that there was like a second way to do this. Because we have about 1,000, it's pretty close to 50-50. When we get to the second half-life, which is right here, this will be down to around 25%. The red line, which is the carbon-14, will be down here. So let's have a look. And stop. So it's not perfect. It should be like around 250. I mean, if it's, again, like 1,000 is not really enough for this to give us perfect proportions. But it's roughly 1/4 are left. And then let's go to the third one. And that should take us to like the 1/8 mark. And that's very close to 1/8. So it's a half, 50%, a quarter, 25%, an eighth, 12.5%. Okay. So let's reset all those nuclei again and try that again. So if you just watch the red ones, so here they go, they're transforming into nitrogen-14. After 1 half-life, it's roughly 50-50. Half have decayed. After the second half-life, and you can see them up here transforming, turning into nitrogen-14. After 2 half-lives, we're down to like only 1/4 of the carbon-14 is left. And then after the third half-life, it's roughly 1/8 is going to be left. So a half, a quarter, an eighth. 50%, 25%, 12.5%. And I could use the uranium-238, and the only difference here is that the half-life is going to be much, much longer. But, oops, I meant to pause that, reset all nuclei. But how it works is going to be exactly the same. If I let this play, by the time we get to 1 half-life, we're going to be at about 50% of the original isotope remaining, and 50% will have transformed into lead. 50% is 1/2. And then if I let that play again, still decaying. And then after 2 half-lives, down here to roughly like 1/4 of the original amount is left. And I'm only looking at this green line because that represents the unstable radioactive isotope. And then let that play again, and it continues on. And by the time we get to the third half-life, we're at around 1/8 are remaining. So a half, a quarter, 1/8. And it doesn't matter what radioactive substance you're using. The mechanics of this, after 1 half-life, you have a half left. After 2 half-lives, you have a quarter left. After 3 half-lives, you have an eighth left. After 4 half-lives, you have 1/16 left. That just keeps going and going and going like that, and it just keeps getting chopped in half every single time.